Hello everyone, my name is Goodman, and I am a data science major at Bellarmine University, and I've created a periodic table using Python code and PrettyTable, and hopefully this presentation will allow you to make a periodic table of your own. So in Python, PrettyTable, it's set up as a chart, and I will show you that now. So I used it to make a periodic table, having each row and column be the elements of the periodic table, and using a certain PrettyTable class, I've added in a little bit of color with purples and greens. It's faint, but it's there. It allows it to stand out a little bit, and it looks pretty nice. So in order to get started with this table, it's pretty simple. All you need to do is import the PrettyTable into Python and allow yourself to use the commands. To get started, I think it's easiest to assign the PrettyTable command when you're using it, so you don't have to type it, to a variable like X, Y, or Z, or maybe a certain chart name that you would like. And I do that here by assigning X to the PrettyTable command. That'll allow you to use X, and it's much simpler. So with starting the table, you want to use a title. You can add this later, or you can start with it. I prefer to start with it so it looks a little bit nicer when you're getting it going and you're trying to problem solve what doesn't look good or what does look good. And you just use that simply by using x.title, or if you do use PrettyTable, PrettyTable.title, and then you assign it to whatever you would like it to be. The next step is to create your field names. Now, field names can be a little bit tricky. You cannot have blank field names, or we call them headers, and you can't use more than one. So that's why I assigned 0 through 18. That way, I'm not using, let's say, helium and helium again in the same row, so you can use 18 instead of 17, and it's a little bit easier to decide once you're making the chart itself. And if that doesn't make sense, you'll get to see it here at the end, and hopefully it'll clear it up. Something to note when doing PrettyTables, it can get complicated pretty fast, so just take it slow, take it step by step, and if you make a mistake, go back and just try it again. So the more complicated part of PrettyTables is that huge bulk of code. It's not actually that complicated, but when you're looking at it, it can get a little overwhelming. But all it is just individual rows in the PrettyTable, and you're assigning each element to be, in this case, an actual element. So you can see up in the top left on the first row, x.addRow. It's going to be the same command for adding every row. You can see the 1 and then the H. That'll be the hydrogen element in the periodic table. But for the code, all it is just the second element, or number 1 element in the row, and then you see 1, and then the next one is H. And then you go and you have 1 through 18 elements, and in this case it's also elements, and some are blank, and you'll see that. That means that there's not going to be anything there, and it's easy to see, and it just makes it look a little bit nicer. Something that you can do, but it's not needed, is you see in this highlighted box is just a bunch of elements with dashes in between. I figured that it would be a little bit easier to read if the rows were individually spaced out. So in code, it's an entirely new row, just like any other row of elements, but instead it's blank, so that makes it a little bit easier to see. And then in the bottom left, you see a print X. That's going to be your key. If you need something done or changed, but you don't know what it will do, just print it out, run the code, see how it looks, and if you don't like it, you're always welcome to go back and change it. That's the wonderful thing about code. If you make a mistake, it's easy to fix. You just go back and see what's wrong. So this is the table again. It looks pretty nice. You can see now that these dashes in between the elements kind of create boxes, and it's a little bit nicer to read. It's less condensed, and it looks pretty nice with the colors. If you wanted to take it one step further and then see what hydrogen or helium was besides just where it is on the table, you can do that. You can do that by creating a function or simply a bulk of code within a bigger line of code, and you can see what they have. So symbol, atomic number, atomic weight, you might know that, you might not, but just in case, you can define whatever element you have, in case hydrogen, helium, boron, any of these elements, and you can assign them their symbols, atomic number, and atomic weight. And when you call by that function in your code, you can get all of that information printed out to you. So that way, you don't have to see all that information on this table, but when you call by the function, you can see in the output, hydrogen, the symbol is H, atomic number is 1, and atomic weight is 1. I hope that helps a little bit. I will show you the code real quick. So this is what it looks like in the Python code. It's pretty simple. You see what I saw in the presentation, but you can go back and review it as necessary. This is the code in Python, or the PrettyTable in Python. It looks pretty nice. And then this is an example of one of these functions. So you see the hydrogen function, a symbol is assigned to H. Since it's not a global variable, you won't mess up stuff like, let's say you have helium, lithium, all of those examples there. You won't overlap because it's not a global. So let's go here. I will do another example. We'll add a code. So let's say we want to see what helium is. Helium. And you print it. And it gives you the symbol He, atomic number is 2, and atomic weight is 4. I hope you've enjoyed. This is a little fun project that I had to work on, and I hope you've learned something. Thank you.